Have you ever wondered why, when you put something in water, it seems as if its weight is much smaller than the actual weight? For example, even if you have a very heavy object inside water, you are able to lift it because it's going to sound as if it is much lighter than the actual weight it has. Well, away from water, when you've got something that is hanging on a scale, so you notice that this scale is always fixed. This should not be able to move when you're measuring something. Otherwise, if the string which you've tied your scale onto is able to move, it's going to tamper with the reading of anything that you are reading. For example, assuming you sell in a butchery, you sell meat. So if this thing is able to move, if that cord, or I don't know what you've used to tie your spring on, moves up and down, the reading here is going to be tempered. You can either make a loss, or you are going to make too much profit, because those who you are selling are going to make a loss. So that is due to weight and weightlessness. So let's take an assumption where we have got this as our spring. Now let's say this is fixed. Okay. So if this is fixed and then you put, let's say, a bucket here, a bucket of water. Let's put it in that manner. So this bucket is carrying some water. So if this is fixed, and then you see that the spring reads, it points somewhere there. So where it is pointing, that is telling us that is the weight of the bucket together with every content in the bucket. Okay. Now, assuming what we have there is not fixed, it's able to move up and down. So let's say this thing is able to move up and down as like an elevator. Okay. It's not fixed. That means it's able to move up and down. Notice that this bucket which you have here has got a weight, and weight always points downwards. And because of that, there is also a force that should be able to balance this weight, and that force goes in the up direction. That is the tension. Let's say maybe there is a tension in this place which is balancing the weight of this bucket. Okay, let's say there is tension, then tension always points in the up direction. So tension is simply a force that is in a cord or a rope, anything else that you are able to use to pull something. So there is a tension force there which is pointed in the up direction, which is balancing the weight force. So let's consider some cases. Case 1. Let's consider where this elevator is not moving up and down. So this, we are saying this is fixed. It is not moving either up and down. So we are saying the elevator is at rest. So whenever something is at rest, that means it's not moving, the acceleration is 0. Now let's consider the forces which are acting on this bucket. Okay, so we're going to say the net forces in the y is equal to, we have got a downward force which should be balanced with the upward force, because something that is going up and down, they should be balanced. So one is going down. Let's take down motion as, let's say, okay, let's take down motion as negative. Let me do this. Let's take up as positive, just as we consider the x or y plane. This is the positive and then this is the negative. So let's consider tension as being positive and then the weight being negative. So that means the net force in the y, we add what is up and down together with the sign. So what is up, we have got tension, and then what is down, we have got weight, but remember it's negative, so it's going to subtract. Now net force is found by mass times acceleration, and that is going to be tension minus weight is given by mass times gravity. Now because acceleration is 0, that means this portion is going to give us a 0. So we're just going to have 0 is equal to T minus mg. So if we take the mg over the other side, we are going to have T being equal to mg. So that means this scale is only going to read the weight of the bucket and everything in it. There's nothing else. So that is going to give us a true measurement whenever the elevator is at rest. Now consider case 2. What if the elevator is moving at constant velocity? It's either moving up or moving down, but it is at a constant velocity. Okay, let's say it is moving up at constant velocity. Alright, so it is going up at constant velocity. So we're going to say the net force in the y is going to be equal to what is taking it in the positive will be the tension. Remember, it is even going up, it is going towards the positive. Okay, that is the tension. And then minus the weight still, which is going down, minus the weight. Now notice that this thing is moving at constant. Whenever we have got this word constant velocity means there is no change in velocity. The only way that we can have an acceleration is when there is a change in velocity. So whenever velocity is constant, that means acceleration is 0. So that means still the net force is going to be equal to 0 because there is no acceleration. Okay, so that will be 0 is equal to tension minus weight. And this will still give us, we take the weight over the other side, that will give us tension is equal to weight. And we know that weight is given by mass times gravity. So if something is moving at a constant velocity, same, the tension reading, the scale reading will be equal to the weight of just the bucket and every content in it. Alright, so having seen that, let's consider some cases where it's not moving at constant velocity, it's not at rest. So what happens? Alright. Alright, okay. So let's consider case 3. So case 3 where the elevator is accelerating upwards. Okay, it is accelerating up. So it is moving in the up. So because this is moving in the up, remember we said take up motion to be positive and down motion to be negative. So if it is accelerating up, it means it's going to have positive acceleration. So therefore the net force in the y is going to be given by what is making this thing to go up. Okay, remember there is the elevator there. In the elevator there is a tension, and that tension is simply the same, like it's the tension which is taking this weight upwards. So it will be tension which is balancing. So the tension is the upward force due to the elevator, and then minus what is making motion reduced is the weight of this bucket. So that will be minus the weight. Okay, so we are saying net force is tension minus weight. But because this thing is accelerating upwards, there is a positive acceleration. Okay, so that means the net force in the y will be given by mass times acceleration. We are saying in the y because it's just moving up and down. It's not going forward, it's not going behind. Okay, so that will be mass. Remember the acceleration is positive, that's why I've just written like that, and that will be tension minus weight. And that will be equal to mass times acceleration being equal to tension minus, we know that weight is given by mass times gravity. So for us to remain with tension alone, let's take that side. So that will give us mass times acceleration plus mass times gravity is equal to tension. So that means what will be the reading on the scale when something is accelerating upwards will be much more than the actual. As you can see, this is the weight of the bucket, and then there is also the acceleration of the system. This is the force due to the acceleration of the system. So the force together with the weight of the bucket are going to be added together, and that will give the reading now on the scale. So the reading will be much higher than the actual reading. Okay. So the reading will be higher than the actual reading. Alright, now let's consider case 4. What if the elevator is accelerating downwards? So it accelerates down. Now remember, when it is accelerating down, the acceleration is going to be negative because it's going towards the negative direction. So that means the net force in the y will still be equal to what is going up is the tension, what is going down is the weight. But net force, like force according to the Newton's second law, is found by mass times acceleration. So this will be mass, but the acceleration in this case is negative. And that will be equal to tension minus weight is given by mass times gravity. Okay, in that manner. So this is going to give us negative mass times acceleration being equal to tension minus mg. So if we want to remain with tension, we are going to take this mg the other side and it becomes positive. So that will give us tension is equal to, when mg goes outside, it will be positive mg, and then the ma is still negative that side. So that becomes it. So whenever something is accelerating down, when the elevator is accelerating down, the reading on the scale is going to be less than actual. That is why we can see from the weight of the bucket together with the content, we are removing the force due to acceleration. So it will be less than the actual. Alright, that is our case 4. Let's look at the last case. What if something is dropping freely? So that would be case 5. Freely falling. Remember, when this bucket is freely falling, it is going in the negative direction. So the acceleration will also still be negative. So the net force in the y is given by still the tension, which is going up, minus the weight. So net force is given by mass times acceleration. That will be tension minus weight, which is given by mass times gravity. Now this net force, because this thing is dropping free, it is falling freely. Whenever there is free fall, the acceleration will be the acceleration due to gravity, and so that will be mass. The acceleration then will become g, because it is a freely falling object, and that will be equal to tension minus mg. So in that manner. So we have even left out something here. Remember, this thing is freely falling. That means the acceleration is supposed to be negative, because it's going in the negative direction. So we are saying that is mass, the acceleration is negative a, not just a. Then that will be tension minus mg. And then it is from this that we are saying that it is freely dropping, and so the acceleration will be due to gravity. That will be negative g, and that will be equal to t minus mg. So if we take this one, this side becomes positive, so that will be mg, and then this is still negative, that is negative mg, and that will be equal to tension. So we notice that mg minus mg will be 0, so the tension is going to be 0. That means the reading on the scale is going to read as 0. Whenever there is something dropping freely, it will seem as if there is not anything that is attached to the scale when the elevator is falling freely. So this will appear weightless, as if it doesn't have any weight. So these are the cases that we need to understand when we're talking about weight and weightlessness. Let's consider one question. So we've got a 45 kg woman who stands on a spring scale inside an elevator. So the scale reads the force with which it pushes upward on the woman. Okay. Now what does the scale read when the elevator accelerates upwards at 3.6 meters per second? Let's say This is the same case. We are saying net force is always given what is going up first, which is going in the positive y, and that is the tension, and then what will be going in the negative, that is the weight. Now for the first case A, it accelerates upwards at 3.65. So when it is going upwards, that means the acceleration is going to be positive. So that is mass times the acceleration, which is positive acceleration, is going to be tension minus the weight, which is mg. So the mass we've been told is a 45, and then the acceleration is a 3.65, and that will be equal to tension minus the mass, which is still 45, and then g is 9.8. So that will give us, if we multiply 45 by 3.65, we get 164.25, and that will be equal to tension minus 45 multiplied by 9.8. That will give us 441. So to remain with tension, we are going to take this over the other side. So that will be tension is equal to 164.25 plus 441. So the reading will show as 605.25. This is tension. Tension is in newtons. That's a force. So that will be the reading when something is accelerating upwards. Now what will be the reading when it is accelerating downwards? It's the same formula. The net force is given by tension minus weight. But the net force will be mass. The acceleration is going to be negative because this thing is going in the down direction. That will be tension minus weight, which is mg. So the mass is still 45. The acceleration is the same, but it's going in the down direction, so it will be negative 3.65. And that will be equal to tension minus mass, which is 45, then gravity, which is 9.8. So this is still 1, but there will be a negative 164.25. That will be equal to tension minus 441. So if this goes the other side, it becomes positive. Therefore, tension becomes 441 subtract 164.25. So the reading is going to show as 276.75 newtons. Notice that when something is going down, the weight is going to be much lower. Like if you consider the weight of just the person, just the weight of the person, weight is given by mass times gravity. The weight is 45, the mass is 45, g is 9.8. So that is going to give us 441 newtons. So in case where something is accelerating upwards, the person will seem as if is much heavier than the actual weight. But when something is accelerating downwards, the person will seem as if is much lighter than the actual weight. So that is about weight and weightlessness. Thank you so much for watching the video. Stay blessed.